Okay, let's quickly recap where we left off yesterday. During yesterday we talked about price elasticity of demand. We called that E with the little subscript P, and if you recall, the formula for that was the percentage change in quantity divided by the percentage change in price. And we know that these always move in opposite directions, right? If we increase the price, the quantity will go up, or go down, I'm sorry. And if we decrease the price, the quantity will go the other direction. So by convention, price elasticity is always a positive number, so we threw these absolute value bars around it just to make it clear. And the way we interpret this is this visual demonstration that we did. What we're going to do is, remember, we hung on this end, we hung percent change in price. So we're like pushing down on price here. And then what we care about is the response on this side. We hung this flag over here, and the response was the percent change in quantity. And then we saw that when we pushed down price, quantity went up, and vice versa. If we pushed up on price, then the quantity went ahead and went down. The way to interpret the elasticity here was essentially where we put this fulcrum. So I'm going to put a nice E in the middle of the fulcrum here. When it was in the middle, we called that an elasticity equal to 1 because the sensitivity was equal on both sides. Like a 10% increase in price created a 10% decrease in quantity. When we wanted this situation to be inelastic, so we wanted quantity to not be too sensitive to changes in price, we had to put the fulcrum, say, over here. And this would be inelastic. Because when we put it over here, we have big giant swings in price, creating small changes in quantity. And so that would be the inelastic place to put it. And then for elastic demand, that means it's very sensitive to changes in price. We put the fulcrum over here. So that means any small changes in price, we wiggle this a little bit, we get these big giant swings over here in quantity. So that's essentially where we left off yesterday. And then as a quick reminder, when we're not given those percent changes, we needed to use this animal called the midpoint method here to come up with percent changes, and we only use this in Econville. And I mean, just to give you a little more insight into why we do that, it turns out that elasticity is really only measured at a point along the demand curve. So if we draw this here, we'll have a demand curve, and we're trying to measure elasticity at a specific point. The way to do that is you kind of take 2 points near it and you estimate it using the midpoint method. For those of you who've taken calculus, you might see this as something familiar when, like, if I just drew a general function and I'm trying to find the slope of the curve at this point, you take the derivative, but before you could take the derivative, the way we figured that out is we would actually find 2 points near that point we're trying to find the slope and draw a line between those 2 points to kind of estimate what the slope was at that point. And that's really what we're doing with elasticities. We're trying to find an elasticity at a specific point, and we're using 2 points around it to estimate it. And the way we estimate is using this guy called the midpoint method. And then we concluded with these 2 simple examples, which you don't even need to use the midpoint method here because the percent changes are given. And then computing elasticities, once you have the percentage changes, is just a simple ratio, finding that fulcrum point. So in this case, we had 10% change in quantity, so we put that up in the numerator here, and 2% change in price. Divide those two, you get 5, so that's a very elastic response. Small change in price created a big change in quantity. In this one, we had 10% change in price leading to a 5% change. We divide those, you get 0.5, so this one would be an example of inelastic demand. So here we're moving on to the slides for today, which is I call elasticity part. So here we're going to discuss a little bit more about the interpretation of price elasticity, and I mentioned how it changes along the demand curve. We're going to do a little more on that, and then we're also going to think about these other elasticities which were in module 48. So rather than understanding how demand changes in response to price, we're going to think about here, I move to the next slide here. We're going to think about how they also change with respect to income, cross price, and then also elasticity of a supply curve. So we're here, this is where we are in the AP syllabus today, still in this same section 4. think I touched on some of this already, but just to highlight again, the key learning targets for today is we're going to do a little more on interpretation of elasticity. The exercise I'm going to have you work on is how this thing changes along a demand curve. Sometimes that's not intuitive to folks. If I draw, say, a linear demand curve, you look at that and you see a constant slope, and so your intuition feels like, oh, that should be the same sensitivity along the entire curve. Turns out that that's not the case. We're going to see that the sensitivity to price changes on a percentage basis is very different along a linear demand curve, and that's what we're going to do in the exploration. This idea about what happens with revenue is a really key reason why we care about elasticity. If you think about a business, their total revenue is a simple equation. It's the price that they charge for their product times the quantity they sell. And businesses, unless you're in a perfectly competition market or perfectly competitive market, you can set your price. And so the question is, when you change your price, you want to understand what's going to happen to your quantity. If you raise your price, if you think demand's going to go way, way down, you might be afraid to do that. Or if you're going to lower your price, you want to make sure that demand goes up enough to make up for it. And so we're going to look at how elasticity relates to this idea of total revenue, because that's one of its key uses. And then we're also going to talk about these other elasticities that I just mentioned. So before we talk about elasticities and how they move along a generic demand curve, I think it's really helpful to just talk about the two extremes. Just like we do this a lot in economics, we think about the extreme cases. And we have these two cases, and this first one is going to be perfectly inelastic demand. So think about that word inelastic, and it's perfect inelasticity. That means there's no sensitivity whatsoever to a price change. And so when that happens, our demand curve literally is going to be a vertical line, because the quantity is going to be the same thing no matter what I do to that price. And these kind of goods don't exist in reality, but you have ones that are nearly perfectly inelastic in terms of demand, and we talked on some of those, like smoking, cigarettes, that kind of thing. Maybe gasoline in a certain price range is going to be very close to a straight up and down demand curve. And then you have the other extreme where any price change creates a kind of a huge response in your demand, and at the very extreme we have what's called perfectly elastic demand. And that when that happens, that means at this price we'll buy any quantity, but what happens is, as soon as that price goes above it, the demand drops off to zero, which is about as sensitive as you can get. Or the other direction is, if I lower the price a little bit, the quantity demand, it becomes actually infinite. So those are, again, the two theoretical extremes that are important to take note of. Maybe a quick note on vocab here. There's the spectrum of elasticities, and these vocabs are important because when they use these terms on the test and also just in problems, you want to make sure to interpret them the right way. So we just talked about the two extremes here: perfectly elastic, which means the elasticity is actually infinite. And you can see that from if I'll just again write the equation up here: percent change in quantity over percent change in P. Perfectly elastic is going to be infinite because any small change in price is going to create an infinite change in quantity. Unit elastic is when they're one-to-one, when that fulcrum's in the middle. So we're going to call that elasticity of 1. Perfectly inelastic means that no matter what I do to my price change, the percent change in quantity is 0. So we get 0 over something, which gives us 0. And then between those key points, we're going to say if it's greater than 1, that means it's pretty sensitive, but not infinitely sensitive. We're going to call that elastic. And then if it's between 0 and 1, we're going to call that inelastic. So again, when you see these terms elastic and inelastic, they have specific meanings with respect to what the elasticity actually means. It's not just like a qualitative description. So this page here just has some estimated price elasticities of demand. Some economic researchers like to try and do this to understand how products and their sensitivity. So, if we were in class, we could have a quick discussion on these and tell me what you think about them. But you see a theme here. These inelastic demands, ones that have price elasticity less than 1, are things like just food and staples, kind of everyday products: eggs, beef, paper, gasoline. And things that have a higher elasticity to demand, like you you're more sensitive to changes would be things that I'm not going to call them quite luxuries, but things that are a little further away from just the bare necessities. Housing's an interesting one. That could be maybe more demand for purchased housing, that when you have more money, you're more likely to buy a house versus rent. Restaurant meals, clearly, if restaurants get pretty expensive, you're just going to eat at home. Same thing with airline travel. These are more discretionary, and you can choose to do other things when the price of them is more expensive. So here a key question. We're speculating on those a little bit right now, but what is it that actually drives price elasticity of demand? Well, the first thing is the availability of close substitutes. If it's easy to find close substitutes, you're going to definitely be more price sensitive, right? If you're thinking about the price sensitivity of beef, and there's pork and chicken and other fish available or something, the fact that there's a lot of substitutes is going to make that more elastic. We touched on this in that earlier slide too. Next, necessity versus luxury. The more luxury a good is, the more sensitive you are going to be to its price. So when you're deciding between the relative elasticity of two things, you should decide whether you think it's a luxury good versus a necessity. And then this last one is share of income. Or, I'm sorry, not last one. Second to last one. Share of income spent on the good. If it's a small share, it's going to be more elastic. So if it's like a little small thing, you're going to be much more sensitive to it versus if you have to spend a lot of money on it versus as a percentage of your income. And then this last one is a time dimension. So given more time, things become more elastic. A typical example would be, if gasoline got up to $6 or $7 a gallon, in the short term, we might say, we just have to suck it up and go buy gas because we have to drive. But over the long term, we would probably find more ways to respond to demand less gasoline. Go either buy electric cars or use more public transportation. And so, with enough time, everything becomes sort of elastic in the long run because you'll just find other ways to adapt. But sometimes you need time to do it. So in the short term, things are less elastic. Here, this is really where I'm going to have you do the in-class exploration now. I guess the key point here, again, is that elasticity changes along the demand curve. So that's one of the key learning targets, is to understand how that works. And then the exploration is also going to look at this idea of how total revenue and price elasticity are related. And this was that earlier I told you this basic equation of how revenue relates to price and quantity. So I'm not going to say much about this now. I'm going to say more about that in the video of the in-class exploration and give you the key takeaways for what to get about how things change along the demand curve, and then how revenue is a factor as well, or how revenue is impacted by elasticity. And then to wrap things up here, I just want to highlight some key ideas about these other elasticities. So we've been talking solely about how quantity changes in response to price change of that good. Quantity can also change for other reasons. We know why demand curves shift. You can make more money, you can have changing preferences, that kind of thing. And so that's what's going on with these different elasticities. So cross price elasticity of demand, maybe we could call that E, put cross price underneath as the subscript or something like that. And notice how in the top it's still percent change in quantity of my good. The only thing I'm changing is what's in the denominator, what's responding to. So instead of putting percent change in the price of the good, I'm going to put percent change in the price of the other good. So like with substitutes and complements, and we'll talk a little bit about that more in class, but that's kind of what the idea is here, is you're changing the price of another good, what happens to the price of my current good. And then here we have, I change my income, what happens to my demand for a good. So we remember we had normal goods and luxury goods, and so we had different ideas of what could happen there. Normal goods, I want more of when I make more money. Inferior goods, I want less of when I make more money. So you can figure out what kind of good something is by knowing its elasticity. And then lastly, we had this notion of price elasticity of supply. And notice this looks identical to the formula for demand. Percent change in quantity over percent change in price. The only difference here is that it's on the supply piece of the equation. So when we graph that demand, supply, We're just looking about sensitivity on that curve, but all the principles still stay the same, midpoint method, etc.